On January 31st, 2017, GitLab experienced a major outage of their online repository hosting service. The primary database server experienced data loss due to a combination of malicious spam attacks and engineering mistakes that occurred while trying to respond to those spam attacks. GitLab responded to the event transparently. The company set up a post-mortem describing the event in detail. In subsequent posts, GitLab expressed sympathy for the employee who made engineering mistakes that led to the deletion of data. The employee was not judged or disciplined for an error that was quite understandable. The response from the developer community was very positive. Engineers know that building cloud services is hard, and engineering is as much about avoiding errors as it is about appropriately responding to the mistakes that inevitably happen. GitLab is a developer platform that combines repository hosting with several other features, such as issue tracking and code review and CD. Today's guest is Pablo Carranza, who works on infrastructure at GitLab, and in this episode, he walks us through GitLab's product, the engineering stack, and the post-mortem of the outage. We also discuss working at Amazon and the importance of post-mortems and culture, which I found quite an enjoyable conversation because I encountered these things at Amazon myself. So it was a great conversation. Enjoyed talking to Pablo. For more than 30 years, DNS has been one of the fundamental protocols of the internet. Yet, despite its accepted importance, it has never quite gotten the due that it deserves. But today's dynamic applications, hybrid clouds, and volatile internet demand that you rethink the strategic value and importance of your DNS choices. Oracle Dyn provides DNS that is as dynamic and intelligent as your applications. Dyn DNS gets your users to the right cloud service, the right CDN, or the right data center, using intelligent response to steer traffic based on business policies, as well as real-time internet conditions, like the security and the performance of the network path. Dyn maps all internet pathways every 24 seconds via more than 500 million trace routes. This is the equivalent of 7 light years of distance, or 1.7 billion times around the circumference of the Earth. With over 10 years of experience supporting the likes of Netflix, Twitter, Zappos, Etsy, and Salesforce, Dyn can scale to meet the demand of the largest web applications. Get started with a free 30-day trial for your application by going to dyn.com/sedaily. That's dyn.com/sedaily. After the free trial, Dyn's developer plans start at just $7 a month for world-class DNS. Rethink DNS. Go to dyn.com/sedaily to learn more and get your free trial of Dyn DNS. Pablo Carranza is an infrastructure lead at GitLab. Pablo, welcome to Software Engineering Daily.
Hi, thanks.
GitLab is a developer platform. It combines a Git repository with a bunch of other features. Describe the GitLab product.
So GitLab is basically a Git repository management with wikis, with issue tracking, with CI/CD pipeline, monitoring pages, and it's basically the whole development infrastructure you're going to need that you can install on premises.
This was a challenge that other people had worked on prior to GitLab. What was the unsolved set of problems in the repository management, the wikiing space that GitLab has been working on?
So honestly, it was started in 2011 by Dimitri. I don't know exactly what he was looking for, but in general, he didn't find something that was useful enough for him that he can run on premises. Back at that time, there were a couple of solutions, but these solutions were, each one, you had to build your own, right? You had to build your own repo management. You had to build your own issue tracker. You had to basically get all these pieces that were separated and join them all together to get something that was covering all the needs. GitLab offers the whole package, right? You just install one package and you have it all.
Why do people want to run their Git hosting and their CI/CD stuff, etc., on premises?
Well, it depends on the company, right? You have companies that cannot use the cloud, for example. You have companies that want to have everything in-house, right? Also, you have the issue of what happens if your service goes down. You cannot actually perform any work, right? There are many reasons.
Right. Yeah. So if I'm just like a rogue developer and I like to throw everything in the cloud, can I still use GitLab?
Yeah, there's one more thing I wanted to say, and it's that
sure.
Git is also a distributed system, right? The idea of Git is that you can have multiple repos all around the world, right? Each client can have its own repo. So concentrating everything in a single place, it's kind of an anti-pattern for that.
Right. Yeah. So what is the typical strategy that a distributed company that is using GitLab with a bunch of repos in different places, what is their strategy for repository management?
So you can have a single instance if you want, and that's going to be fine. You can have it locally. You can also use mirroring if you want to have multiple places. And there's another product we're working on, which is GEO, which allows you to have closer copies of your repo, of your whole infrastructure, actually.
Okay, well, let's first talk about if I have a GitLab deployment and my entire company is entirely in one place. What is the architecture for the GitLab application that I'm deploying on premises?
Okay, so the architecture is kind of simple. It's just a Rails app, which is going to be using a database, namely Postgres and Redis for running Sidekiq, and then a local file system, right? That's quite simple. There are a couple of components, like, for example, Workhorse that is written in Go. There are a couple of things that are a little bit specialized right now, but in general, a single installation of GitLab is quite simple.
I see. And what is if I have a single deployment, is there any relationship between my on-premise deployment and the GitLab product, the GitLab infrastructure that's in the cloud, like under the GitLab company?
So the GitLab installation, the GitLab.com, the website, that's built using the same package we ship to our customers. It's an instance of GitLab EE, with the caveat that we have a larger infrastructure. We have multiple instances running different parts of the system, and we are interconnecting them. In general, that's pretty much it. The main difference is probably the scale and the solutions we need to use to reach that scale.
Can you talk more about what is under the GitLab, the company's infrastructure, the company's deployment of GitLab, because it does have a lot of scale. But if everybody's hosting their stuff on premise in their own deployments of GitLab, what exactly is being stored in your own GitLab deployment? So
our GitLab deployment, in the end, is like any other GitLab installation, right? But what we're storing there is basically Git repos, and we're also installing all the metadata, right? For example, issues, all the comments on your issues, etc. Right? All this data that you're using for your daily work, right? For example, if you push your code, you're gonna create a merge request, you're gonna have comments in it, you're gonna run your CI/CD pipeline. You can have your own personal runner for running that, but you can store all the information, all the metadata from this work and your repo in GitLab.com.
So even though I have my repository on premise, so if I'm like a medical company and I have to host my own installation of GitLab, the GitLab.com can host the metadata, like the issue tracking. Is that what you're saying?
So what I'm saying is that GitLab, the package, it's a full application, right? You can have your metadata, you can have your issues, you can have your merge request, you can have your code, you can have everything on premises, right? And you're completely detached from GitLab.com.
Right.
Right. GitLab.com is another instance.
Okay, all right. So when you're talking about all of the data that's being stored in the GitLab.com and the GitLab instance, you're just referring to metadata about GitLab itself, the GitLab product, the data that the company is managing.
So let's say you have a repo, right? Let's say you create a project, right? You have this remote repo from the Git perspective, right? Where you can push and you can pull, right? The classical Git operations. You code something, you commit, you push. You push to GitLab.com, right? Now, you create an issue because you want to have something done. You create that in GitLab.com. You can have the whole development cycle in GitLab.com, right? But now let's say that for some reason you want to run it yourself. You install the package and you have your own personal GitLab.com. It's completely detached.
I see. And I can choose whether to sync it with GitLab.com if I want, or is there a way to sync it to run everything on my computer, on my own local computer with all my issues and stuff, and then sync it later on with the GitLab cloud?
You can import. Yes, you can import from a different instance. There's mirroring you can do that's going to affect only the repos.
So let's talk about the GitLab infrastructure itself, because if you are, you've got a product that can host. It could basically host anybody just like a remote Git repository management system, but it can also be hosted on premise. But I guess we should talk about the larger cloud instance, the cloud deployment of GitLab itself. What's the infrastructure, or what are the unique scalability challenges of building a service that's going to manage lots and lots of user repositories?
So the main challenge for us has been for quite some time storage, unsurprisingly enough. The thing is that we're storing a lot of data lately in between repos. I think we have something like 76 terabytes of Git repos, and we have something like another 50 terabytes of regular files like uploads, logs, etc. Git particularly is extremely expensive, both from the CPU perspective and the IOPS perspective. And also there's the problem of we just keep getting more data, which means that we need to scale horizontally. So that's one of the main challenges we had. The second challenge we had was with the database itself. Again, same issue. We're just growing a lot.
What are some of the architectural philosophies of GitLab that you employ as the product is growing?
GitLab started being a Rails application, which is basically that it was a monolith. And the problem with that is that at some point, so it's great for building a product, but the issue is that at some point it just doesn't scale anymore. The philosophies we're using now is that we're trying to have a data-driven approach to understand exactly what the problem is and what do we need to do to fix it, which means that we do a lot of data gathering, and then we do a lot of analysis to understand what the bottleneck is, right? For example, in the storage case, we try to solve that first with a little bit of a brute force attack using a distributed file system. It just didn't work. We analyzed the data and we decided to go a different path, which was to extract Git and build basically a Git as a service per se. That's a project called Gitly because of the way it behaves. With this, it's pretty much the same. What I mean here is that you need to adapt, you need to learn, you need to try things, and you need to be wrong soon, and then you need to iterate. As you iterate, you're going to be learning more, and as you learn, you're going to be adjusting your path.
Your application sits on layers of dynamic infrastructure and supporting services. Datadog brings you visibility into every part of your infrastructure, plus APM for monitoring your application's performance. Dashboarding, collaboration tools, and alerts let you develop your own workflow for observability and incident response. Datadog integrates seamlessly with all of your apps and systems, from Slack to Amazon Web Services, so you can get visibility in minutes. Go to softwareengineeringdaily.com/Datadog to get started with Datadog and get a free t-shirt. With full observability, distributed tracing, and customizable visualizations, Datadog is loved and trusted by thousands of enterprises, including Salesforce, PagerDuty, and Zendesk. If you haven't tried Datadog at your company or on your side project, go to softwareengineeringdaily.com/Datadog to support Software Engineering Daily and get a free t-shirt. Our deepest thanks to Datadog for being a new sponsor of Software Engineering Daily. It is only with the help of sponsors like you that this show is successful. So thanks again. I know a number of shops where when their Rails application begins to creak, they move to JRuby, so they start to be on Java. Is that a strategy you guys have considered?
Not really. We do use a set of native gems, which doesn't allow us to start doing JRuby. And also, it's not so much about the language. I don't think that Ruby is to blame here or RMI. I think the issue here is that when you're building a product, you are trying to deliver the most value to the customer, the sooner the better. And that's going to push you to do things in a way that you're not considering scale soon. As you grow, you start seeing where the bottlenecks are. The bottlenecks are not about the language itself. The bottlenecks are architectural issues. Not by moving to JRuby, not by running a faster car, you're going to be running faster in the same road.
There is, of course, the classic premature optimization criticism people will make, where if you say, oh, if we build this way, we'll be able to scale to thousands and thousands of users, and then you'll very quickly be shot down and say, oh, that's a premature optimization. Do you think that holds true for the GitLab product? Or do you sometimes look around at the architecture and say, oh, I wish that people would have thought more long-term about this?
It's tricky. The way you can remove the judgment of premature optimization is by having data. When you have data, the conversation changes a lot. And I think that's the path we're following now. We're gathering data. We're trying to understand exactly what the bottleneck is. Because multiple times, the problem with premature optimization is that you will say, I think that the problem is this. Therefore, if we do this or that, we're going to be running much faster. But that's an assumption. Now, what data do you have to actually prove that assumption? Well, that's when the game changes. If you have an assumption and you have an experiment, you go and run your experiment, you gather the data, then you can actually make an informed decision. With that data, you know that reality actually is this way. Therefore, you can start adjusting and you can start planning in a way that is going to be easier and it's going to actually be much more effective, much more cost effective, right? From the I wish people would have thought about X. Again, I think that by the time the product was being built, the goal was to ship a product, and I think that we succeeded there.
You and I have both worked at Amazon. We could talk about that more later, but this brings to mind the story of the S3 team. I don't know if you know the story, but when the Amazon S3 team was presenting to Bezos and they said, okay, here's our product. And Bezos said that if this works, if it has any amount of success, the product will fall over and therefore it will not be a success. And that will not work because it's core infrastructure. And so the team went back to the drawing board. They spent like another year or 6 months or something, reconfiguring it. And I always found that to be an interesting story because a lot of people would just say, yeah, let's ship it. And they wouldn't prematurely optimize. But it's sort of an example where it seems like Bezos might have been right. Like, oh, you actually do want to prematurely optimize for S3 because you can't lose trust on a product like that.
Yeah, but also you have to think that the case of Bezos is that they were already in a large scale. So Bezos was seeing the growth they were having, and he was actually challenging this is not premature optimization. This is required. This is a hard requirement.
Oh, did they have EC2 already at that point, or are you talking about the Amazon.com marketplace?
The Amazon.com marketplace in general.
Right.
The growth of it was insane. I mean, the numbers they're running is insane.
Yeah, and I don't remember, was S3, I mean, were they originally thinking like this is a product that we're just going to dog food internally first and then deploy, or?
No, I don't know about that.
Okay, all right. Well, anyway, so GitLab is mostly hosted on Azure, and I've talked to a lot of people about AWS. I've talked to a lot of people about GCP. I'm going to Microsoft Build next week, and I'm eager to learn a lot about Azure because, as I understand the cloud rankings, AWS has the most market share, Azure has the second most, and Google has the third most. And the fact that I haven't done any reporting on Azure, despite the fact that it's the second biggest cloud provider, I think removes some of my credibility as a software engineering reporter. So what's been your experience with Azure?
So it's been challenging, basically because we started being a small company, and Azure, I think they weren't really ready to deal with startups, and they were learning through the process. We were learning with them too. Also, I do see that they're going through a process in which they are following the steps of AWS a little bit. For example, not so long ago, they are building this new environment, which is called ARM, Azure Resource Management. And they are making us jump over the fence to this new resource management infrastructure, which is something that AWS did years ago, right? So you can see that they're following kind of the same steps. But also, I do think that if they have the second largest share, that's going to be because they're the main people who run Windows, basically. But we run Linux, which sometimes ends up being that the infrastructure is not really friendly to Linux sometimes. It's improving a lot, and they have really great support people from the Linux side. But you can see that it's a learning process. You can see that we're working together, we're improving the lines of communication day to day to actually get into a better shape because it was really challenging for us.
I don't really understand when you're talking about they're forcing you to make this migration. What does that mean? At what layer of the stack are you having to make some changes?
No, it's not about the layer of the stack. So from my perspective, it's just a hypervisor and that's it. I understand that the changes are particularly internal to their network, as in they had a lot of learning in the classic environment, and with that they're building a new environment which is probably much more cost effective. But I don't have the data to understand exactly why they need this change to happen. What is happening is that they are deprecating all the functions from the classic environment, and that's basically making us move to the new environment.
And does that lead to some outages?
Well, that leads to us having to boot machines on the other side. On the particular case of we using NFS as a storage system, yes, that led us to take downtime.
I see. Speaking of that downtime management process, talk about the monitoring stack. Because you're an infrastructure lead, so you spend a lot of time looking at the monitoring and deployment process. Describe the monitoring pipeline.
Oh, yeah. So we use Prometheus extensively. We actually have a Prometheus team, and we ship it as part of the product because we really believe in that monitoring stack. In general, the way it works is that we have a couple of servers. We have 2 servers for HA, and we have another server which is public. These servers are pulling data from the different hosts, from exporters. These exporters provide the metrics for different things, system level metrics, Postgres specific, you name it. And this data exists in these Prometheus servers, which you can query, which is highly valuable for us. And we also have a Grafana instance, which is showing a set of dashboards. One thing we did, because of the open nature of GitLab, is that we have a private one, which is HA, and that's the one we use internally, and we're basically modifying it all the time. And we have a public one, which is a replicated version of the private one.
What is new about Prometheus? Because I did a couple shows about it, and people talk about how important Prometheus is as a monitoring tool. Explain what Prometheus does differently.
So you come from Amazon, so you know the monitoring tools they have in, right? In the outside world, so to speak, when I joined the company, we had a Nagios installation. The problem with Nagios installations, or the big issue for me with those kind of systems, is that they're host-based. They're great for monitoring hosts individually. When you start using something like Prometheus, you're going to start aggregating a lot of metrics, and you can query those metrics later. And you can particularly start grouping them by service. You can start seeing how these hosts are behaving at the same time, and you can start correlating different data. Particularly, the really useful thing is that you can do that after the fact, right? You don't need to set new checks to see what's going on there. You already have a lot of data, and you can go and play with the data afterwards. You can do discovery of how the systems are behaving after whatever happened, right?
Mm-hmm.
That is extremely powerful. It's extremely powerful because let's say you have an outage or you have a degradation of the system and you have no clue what's going on, then you can go and start querying the information that you already have available, and then you can discover things that are going to explain other metrics you're seeing.
Mm-hmm. How does a deployment work at GitLab?
Okay, so a deployment in our infrastructure, one thing I didn't mention is that we have something like 40 hosts in the front end. Deployment, right now, we use the same package we ship. We use GitLab E, the package. And the way it works is that we basically perform a sudo apt-get install of the package in a specific host that is not getting any traffic. We run the migrations there. And then we perform a rolling install through the rest of the hosts. That's in a nutshell how deployment works. It can be improved because the package is large and it takes time to unpackage. But in general, we're doing the same thing our customers are doing. The reason behind it is that we ship a package. This package has to work for our customers.
So I want to get into this incident that happened back in January where there was a major production event, but because I think it's a great case study in how to handle an incident like this and how to build a productive team around responding to these kinds of events. But I guess before we dive into that, talk a little bit about the process of on-call and what the responsibilities of the team are in keeping the uptime of GitLab and monitoring it for issues. How does on-call rotation work, and what are the responsibilities of somebody who's on-call?
So the on-call we perform is 12 hours. It's a 1-week shift, 12 hours per day, because you need to sleep. And the duties while on-call is, first of all, that you will be the first person who's going to reply to an alert, whatever that alert is. And you also need to investigate whatever happens to the system. You have to be using the monitoring tools to see the health of the system. And you need to leave a sane trace of what happened, if anything happened. For that, we have the runbooks, for example, which are completely public. The way the alerts work is that whenever an alert is triggered, it will point to the dashboard in monitoring. It will also point to the runbook that you need to execute. And it's your duty as an on-call person to handle the problem if it is a problem, of course, update the documentation if it's needed, and in case you don't know how to handle it, escalate.
What does that term runbook mean?
Runbooks are a project. It's an open source project where it started when I joined the company. It was a way of reverse engineering the tribal knowledge. Because I was just joining the company, I didn't know how to do a lot of things. And what I did was I started writing down every action that was being performed. It was a way of generating documentation. Then I started pushing for use that as a way of handling the outages, and we also added alerts. Both the alerts and the runbooks live in the same project because they go hand in hand.
So if I understand how a runbook works correctly, it's, let's say you have an event where our log servers are running out of disk space, and you look up that issue in the runbook and it says, okay, if the log servers are running out of disk space, first check the number of other hosts that you might be able to divert traffic to, and then look at how much space those hosts have, and then consider redirecting some traffic to them. And it's basically like a list of steps. It's like a recipe for responding to an adverse event. Is that correct?
Yeah, it's correct. The basic structure is a pre-check where you're going to say you get an alert of something. You will have a way of checking that you're doing the right thing. a set of checks to perform, and then a possible resolution, and then a post check, and in some cases even a rollback plan.
Mm-hmm. Yeah.
The idea is that when you're under stress, you don't want to think.
Right. And I think, don't runbooks also serve as a decent path to automating some of your infrastructure in the future? Because you might have a runbook that describes something just because somebody has not written the right scripts that can automate that response.
Yeah, that's another plus of this, is that you are actually codifying your reaction to a problem, which means that you can afterwards automate it. Once you have a runbook that is solid and is not going to be changing, you can actually have it automated perfectly fine.
Mm-hmm. Back in January, there was this incident where a database administrator at GitLab deleted a production database, and this was a result of a series of events. It started with spammers hammering the GitLab database by creating little snippets. Explain what was going on.
Yeah, multiple things were happening. One of the first things that happened that we discovered afterwards was that we were having a lot of spammers who were hammering the API to create these snippets. These snippets are used as public snippets to basically gain page rank. The issue was that in the middle of this mess, one of our own employees was marked as a spammer, so it was marked to be deleted. This added a lot of load to the database because it's not so easy to delete someone who's in the guts of the database. You know, there's a lot of issues, there's a lot of things. So this process was failing and was generating dead tuples. At the same time, we had the spammers who were creating new snippets, and we were in the middle of this, blocking this IP, removing these snippets, etc. That added a lot of other load to the database. There was a lot of load being generated because of all this situation. So what happened was that the secondary database lost the replication. The reason why that happened was that we're running PostgreSQL, and we had it set up to follow replication using the wall segments, which is the write-ahead log. The primary database was writing wall segments way too fast for the secondary database to follow it. And at some point, the primary just dropped old wall segments, and the secondary was not able to keep up and just dropped replication completely. We were in the effort of recovering replication, and that's exactly when this confusion happened, and we basically deleted the database. That was the whole thing. One thing to mention here is that this database, this is only about the GitLab.com, the instance. Going back to the beginning of the conversation, none of the on-premises customer had any form of data loss. This was only about GitLab.com and about metadata. What we lost there was some issues and merge requests. No repo was affected whatsoever.
Mm-hmm. Can you describe in more detail the atmosphere in which the accidental deletion occurred? Because there was a number of things going on, and also this team. So there's a great write-up about this. I'll put it in the show notes. But this person who is anonymized as team member 1, they were somebody who was tired. It was kind of the end of the day, and it was just a really unfortunate intersection of timing and these spammers. It's just really bad luck. But describe why was this able to occur? Do you think this was a preventable intersection of events?
I think it is preventable. In honesty, of course, hindsight is 20/20, right?
Yeah.
The person was tired. We were also, because we were dealing with spammers, and it was a little bit of a all hands in deck, because there was a lot of noise going on, and the atmosphere was just what can we do? But it was ongoing. It was an ongoing thing that we were all working in, and nothing else than that. It was preventable from the perspective of there was no safety measurement that prevented this from happening, right? This is something that is easy to say afterwards, But in general, this could have been avoided with a good measurement, with a good automation, right? Just with that, it would have been enough. The thing is
what kind of automation?
Sorry?
Like what kind of automation?
Well, if you only have a simple, really solid script that is going to help you recover the replication, which we had but was not good enough, only with that, you don't need to perform any manual action. The problem with the runbooks, and I think you know this probably from Amazon, is that human error is a common thing. It happens. We're tired. We make mistakes.
Can you describe a little in more detail what caused team member 1 to accidentally delete the database, and then how did they realize that, oops, I made a mistake, and then what did they do after they realized they made a mistake?
So this person was trying to recover replication, and was SSH'd into both databases. It was just a confusion.
Right, and so what did they do after they realized that they had deleted it? What was the path to recovering from this event?
Okay, so what happened afterwards was first this person commented in Slack that I made a huge mistake and was tired. And the rest of the team, what happened immediately was, oh, okay, so what can we do? And all the team started helping immediately to forge a plan to move forward. That's when we started testing. We started basically trying to recover from backups. They weren't working. And we all started basically trying to find the way to move forward.
Yeah, and it sounds like the lack of blame, nobody blaming team member 1 was really a valuable reflection of the GitLab culture.
Yes, blame is useless. If you focus on blame, what you're going to be doing is you're going to be stopping at that point. You're not going to be focusing on solving the problem. What you need to focus at that point is in solving the problem.
Now, some customers did lose metadata to this, but all of the customers are developers. Were the developers who were affected, were they sympathetic?
Yep. I think that was an interesting thing about the openness. When we started trying to find a way of moving forward, we basically got together in a war room in a video conference. We started a document where we wrote the timeline of events to understand exactly what happened and what can we do. And we proposed a lot of ideas in there, right? Immediately we opened this document for anyone to see, and we tweeted, "This is what happened," right? So the service is down because we made a mistake. You can find more about it in this document. So people started jumping in, and we firstly perform a series of debugging of exactly what the path is forward. And by the moment when we had a path forward, the team member 1, basically, he was too tired. He stepped out. So another team member took the lead on moving forward. And when we find a way of moving forward, all we had to do was basically wait to get to a situation where we can restore the data. We were pulling the data from a different data center, and that was going to take a while. So at that point, I think it was Sid who said that we could basically open this and start streaming it. And we said, yep, sure. It's one of the things about GitLab culture is that it's open by default. So it doesn't make a difference to us to work completely in the open.
How far does GitLab take that openness as a default? Because I love when companies are extremely open, but a company like Apple, for example, probably could not be extremely open because a lot of the value of their product is the surprise of, oh, we suddenly released this new augmented reality set of glasses and you're blown away by it. Do you think that there's is there it's just different companies can be different degrees of open?
I think so. GitLab particularly, we develop an open core product where you can read all the code. We have open issue trackers. You can go and read what we're doing. Of course, there's a point where things become private, as in, I don't know, if we're talking about specific person, if we're talking, I don't know, if we're going to be compromising security, of course, that's not going to be in the open. And in general, everything is open by default. There has to be a good reason to make it closed. I think it's because of the nature of the company. Different companies are going to be working differently, and that's perfectly fine.
Artificial intelligence is dramatically evolving the way that our world works. And to make AI easier and faster, we need new kinds of hardware and software, which is why Intel acquired Nirvana Systems and its platform for deep learning. Intel Nirvana is hiring engineers to help develop a full stack for AI, from chip design to software frameworks. Go to softwareengineeringdaily.com/Intel to apply for an opening on the team. To learn more about the company, check out the interviews that I've conducted with its engineers. Those are also available at softwareengineeringdaily.com/Intel. Come build the future with Intel Nirvana. Go to softwareengineeringdaily.com/Intel to apply now. After this event, GitLab did a post-mortem, and I remember having post-mortems at Amazon. They were really important because after an event like this, everybody is kind of has some adrenaline. Their eyes are wide, and I think people are particularly engaged. So it's actually a really good time to pull strategic elements out of an event and be able to integrate them into your culture for later on. Talk about the importance of postmortems and how the postmortem from this event, from the production database outage, how did that affect GitLab going forward?
So we use postmortem. What you're talking about is the COE process in AWS, in Amazon, which is the correction of error. I think it's a great name, by the way, because what it tries to do is tries to understand exactly the root cause why this happened, and you use that as an exercise to understand what took you there. The postmortem is basically the same idea. Is you write a timeline, you go through the events, and you try to understand how did things happen, right? You have this idea of the 5 whys in AWS, which is that you have to ask why 5 times. I think it's a Toyota thing. The idea behind it is that you shouldn't be stopping on the first thing because there's a reason why that thing happened, and there's a reason why the previous thing happened, etc., right? So when you finally reach the root cause, then you can start talking about, okay, so how do we make this not ever happen again? Right. That's part of the continuous improvement kata, right? This is a way of fixing things so they don't happen again. If you have the same problem 2 times, then you're not trying hard enough, honestly. It's the same idea. This is something that I started using with the Rambooks as a way of understanding why things were happening. It was a way of reverse engineering the problems we were having in production to make them explicit and be able to work with them. So the goal with that was to get the Rambooks outdated and change the problems, right? With the incident post-mortem, we already had a timeline. We had a couple of ideas, but we wanted to perform a post-mortem that made sense and that explained the whole thing, all the problems, all the issues we were having, and make really explicit what we were doing about it. Because you're going to have problems. The thing is what you do with the problems afterwards.
Let's talk more about culture. We'll first talk a little bit about GitLab, and then we'll talk about Amazon. GitLab, it's an entirely remote company, right? Or is there some centralization?
GitLab is 100% remote. It's remote only. I think there is an issue in San Francisco used for, I don't exactly know what, but there is no offices. This is actually interesting because we all play by the same rules.
What do you mean?
What I mean is that when you have some people remote, I've seen this when working at Amazon, that you had a team that was split between Dublin and Seattle, for example. And you can see that there was a core of the team somewhere, and then there was the satellite team, right? the satellite team was left, wasn't in all the conversations, right? They were missing data. In GitLab, that doesn't happen because the core is distributed. So we are forced to work asynchronously. We're forced to work with issues. We're forced to use Slack, but particularly we're forced to share data in a written form in a way that is accessible for everyone in the team, which flattens the structure, right? You don't have a group of 2, 3, 5 people who has much more high bandwidth communication. All the people plays by the same rules.
Yeah. What are the costs of that? Because I'm running Software Engineering Daily, which I work with one other person full time, and that's remote. And then I'm building this other company, Ad4Prize, which is about 5 or 6 people, and we're entirely remote. We're distributed across the world. We're in different time zones, and Slack is our centralization point. And I love it. I love the flattening and the standardization. But personally, I do miss some of the super high bandwidth in-person interactions, and that stuff doesn't seem replaceable. So what are the costs to not having some of that in-person interaction?
So you will have this form of interaction. You can actually have a hangout with this person and have a conversation. What matters is that whatever you talk there doesn't exist until you write it down. In general, you will be, we're humans. We do talk. That's the way we are. But the issue, or the big issue, is that when you're only having the conversation with a single person and all the rest of the people is out, the cost per se, maybe there's this chance of, if you are too far away in time zones are hard. And sometimes you will need to talk to someone who's far away, which means you will need to stretch your working hours to be able to talk to this person, which means you will need to reallocate your working hours.
How is your experience at GitLab different than that at Amazon? You were at Amazon about 2.5 years. Were you in Seattle?
I was in Dublin. I was working at Dublin, AWS, networking for 2.5 years, or almost 3.
Right. How was that, and how is it different than GitLab?
Amazon is a huge company. Amazon is like a small country. Everything is moving all the time. You're going to have emails. You're going to have your 600 emails every morning that you need to learn how to skim through. It's a firehouse of communication every morning. But in general, Amazon, locally, it's like a classic company from the perspective of you're going to be working in an office and you will be sharing this sync time with the people. You do have to travel a lot. I traveled to Seattle a couple of times. And I think that the main difference with GitLab, the first difference was the size of it. And at Amazon, pretty much all the problems are, I'm being a little bit naive here, but all the problems are solved from the perspective of you already have S3. You already have a lot of infrastructure, right? You want to perform a deploy, you have Apollo. You want to do this or that. You already going to have a lot of tools that are going to speed you up once you get to learn them.
Once you learn them, which takes like a year.
I think I mentioned once that the onboarding process at Amazon is something like 6 months. That's when you finally understand all the moving bits, because you have to learn while the things are moving. So you have to get into the rhythm of learning. GitLab is a much smaller company. At this point, when I joined, it was something like 50 people. Now it's 150. It's growing a lot, but it's far away from the numbers from Amazon, which means that there are a lot of things that are not solved yet, which means that you do need to work in a lot of different places, in a lot of different. You need to own a much larger piece than what you're going to be owning at Amazon. At Amazon, you're going to be owning a specific problem of a specific team, right? Here, you have to own the whole infrastructure, for example.
What team did you work on in Amazon? If you could, or can you say?
I was in networking, in network automation.
Network automation. Yeah. I just, the thing that was cool about Amazon was just that the energy that I liked was just that the energy level was always so high. It felt like the entire place was pulsing with energy, and I think it's really interesting that they were able to build an organization where that energy really scaled, because I think a lot of companies, when they get big, they start to lose that energy.
Yeah, that's true. Amazon was vibrant all the time, and it looks like it's always trying to find the next thing and doesn't really know exactly what the next thing is. You have large issues to solve in the networking space, for example, in networking automation. There's a lot of work to do there yet. And given the size of the network, which is really, really large, the problems are hard. What you were saying at the beginning of Bezos saying that take this to the whiteboard because it's not gonna work. It's gonna fall off the first time. The first time you wanna run it. With networking, it's kind of the same thing. You are, even if you're building a new product, you have to think about the scale of things at the beginning, which forces you to think in a specific way. The thing about GitLab is that it's also vibrant. It's also fast-paced. I do find a little bit of the Amazon craziness in GitLab, and I enjoy it. One thing I think you mentioned once was that the people that were at Amazon, they can go back to Amazon because you already match the culture and you kind of think that way. And that culture is actually going to go with you. That way of working, that way of thinking. Ownership, for example, is a thing that you're going to have very present because it's one of the leadership principles.
What do you think about the difference between Amazon's culture and culture of other large companies? I'm thinking like Facebook or Google, where they have all these perks and they really make you feel comfortable as an employee. Whereas Amazon, you never really get comfortable, but it seems like the people that come out of Amazon really value their time there. So in that way, it's almost like going to MIT or something and just getting brutalized with how difficult it is. But what do you think are the costs and benefits of the luxurious culture versus the work you to the bone culture?
I think it's different people want different things. The perk of Amazon is that you can innovate all you want. So one of the things that will happen at Amazon is that if you build something that actually makes sense to someone, you're going to be owning it, and you may have a new product from that. I don't know so much all the other cultures because I wasn't there working.
Sure.
But one of the things we were saying when we were inside Amazon is that we don't actually need those perks, right? We want to solve the problem. We want to have this really difficult thing to deal with.
That's the biggest perk.
That's the biggest perk. Right, you wanna have a simple, a nice couch, fine, but that's not what we're here for.
Amazon did have some nice couches.
Yeah, that's true. Depends on the office, though.
Yeah. Do you have any other interesting memories from Amazon? I don't know. I just always like reminiscing with people who have worked at Amazon because I only worked there 8 months, and I wouldn't consider my experience there like a success, but I learned so much that I really just value the company. I treasure the company, and I love talking to people about their experience there. But do you have any just parting memories about Amazon?
I think at Amazon, I learned the value of data. I learned the value of having this scientific approach, as scientific as we can get in software engineering, right? But we used data a lot to drive behavior, for example, in networking. And that was extremely successful from the perspective of understanding exactly what's happening and having the ability to adjust our direction. That is something I brought with me and that we're doing at GitLab pretty much every day. And, you can have a lot of assumptions, but if you measure, you have data, and that changes the game completely.
How do you see the GitLab product evolving into the future? And for people who have not tried out GitLab, what would you say to them to encourage them to try it out?
So to try it out, if you want to have your data on premises, just install the package. It's really simple, and you're going to have a full-blown development system that includes even CI/CD. It's really full, right? It's the whole development OS, so to speak. It's great. How do I see it evolving? I see that the main challenges we're having right now are all in the scale realm. And that's going to help us. That's going to force us to change a lot of the things we're doing. That's going to help us to drive change in a way that we can cope with all these scaling issues. And I think that a lot of really interesting problems are going to come from there, and a lot of interesting solutions, because it's not about only solving the scaling problem, it's about shipping it to the customer in a way that just works.
Pablo Carranza, thanks for coming on Software Engineering Daily. It's been great talking to you.
Thank you.
Thanks to Symphono for sponsoring Software Engineering Daily. Symphono is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symphono.com/sedaily. That's symphono.com/sedaily. Thanks again to Symphono for being a sponsor of Software Engineering Daily for almost a year now. Your continued support allows us to deliver this content to the listeners on a regular basis.
Wow!